Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class. Today we are going to be wrapping up chapter 1, and we're going to be really looking at statements of logic here. This is kind of going to be the last piece before we get into heavy proofs. Okay, so we're going to learn about a lot of very important statements here. So please be honest with me, ask questions like you guys always do. Let's review real quickly what a conditional statement is. A conditional statement, if you remember, is a sentence in the form of if, then. If the hypothesis, then the conclusion. Several declarative statements can be written in a conditional form, such as two straight angles are congruent. We could write that as a conditional. If two angles are straight angles, then they are congruent. So a statement, not 100% of the time, but a very large percentage of the time, a statement can be written as a conditional statement, okay? And a declarative sentence is just something that declares something. Hopefully you know that from English. All right? So let's think about this conditional again, guys. The if part is called the hypothesis. And then the then part is called the conclusion. Okay? So if the hypothesis, then the conclusion. And that is what a conditional is, and we learned about that yesterday. Now, today we're going to talk about negation, something called a converse, an inverse, and a contrapositive. And a negation of any statement P is basically the statement not P, which can be symbolized by the following symbol. That little squiggly line and a P. That little squiggly line in front of that P means not P. That's what a negation is, not. Okay? Now, how does this relate to converse, inverse, and contrapositive? Well, let's check it out. The converse of a statement, my friends, is if Q, then P. So what does that mean? That means that it reverses the conditional. Okay? Let's pretend that in this conditional we have if P, then Q. The converse to that will be if Q, then P. It literally reverses the conditional. It puts the conclusion part where the hypothesis was, and it puts the hypothesis where the conclusion was. The inverse is the negation of the conditional. It states if not P, then not Q. And I can symbolize that by just going like this. Squiggly line P, then squiggly line Q. If not P, then Q. Bless you. It's a negation of the conditional. Again, a conditional, if P, then Q. The converse switches those. They reverse it. If Q, then P. The inverse negates the conditional. If not P, then not Q. And then the contrapositive negates the converse. Let me erase this so it doesn't get confusing. The contrapositive negates the converse. So if, not I not, but if not Q, then not P. So we could say if not Q, then not P. So again, let's just go through it really quickly one more time. I'm not trying to bore you, but I really need you to understand this. The conditional here is if P, then Q. Whatever statement that is, it doesn't matter at this point. Just got to understand how this works. So the conditional is if P, then Q. The converse would be if Q, then P. You reverse the conditional. The inverse, if not P, then not Q. You negate the conditional. The contrapositive, if not Q, then not P. You negate the converse. You with me, boys? Okay, I know this is kind of foreign at first, but I promise you, it's not that bad. Let's look at some examples. Please. For example, I want you to find the converse, the inverse, and the contrapositive of the following conditional statement. If you live in Atlanta, then you live in Georgia, okay? This is an if P then Q statement. This is my P. It's the hypothesis. This is my Q. The conclusion. So the converse reverses the conditional. So the converse would be, if you live in Georgia, then you live in Atlanta. That's the if Q, then P. Okay? If Q, then P. You reversed it. All right? Is that necessarily true, though? Good. Just because you use the converse, that does not mean that the converse is always true. Even if the conditional is true, the converse is not necessarily going to be true. There are other cities in Georgia other than Atlanta. The inverse negates the conditional. So the inverse would be, if you don't live in Atlanta, then you don't live in Georgia. If not P, then not Q. Again, that is false as well. So far we've hopefully learned that the converse and the inverse may not be true. They could be, but they won't always be true. They may not. And then the contrapositive negates the converse. So in this case, if you don't live in Georgia, then you don't live in Atlanta. If not Q, then not P. Yes, sir. You just said it backwards, and I'm so proud of you, son. That's the next thing I was going to show you guys. Notice that both the conditional and contrapositive are true. If the conditional is true, the contrapositive will always be true. But it's not the other way around. No. If the conditional is true, the contrapositive will always be true. Okay? But if I give you the contrapositive, and I guess if you work backwards, you'd get to a true conditional statement. Does that make sense, guys? Promise? I know this is all foreign, but it makes sense? All right, good stuff. Now, that's a theorem that I just talked about. Our third theorem states that if a conditional statement is true, then the contrapositive of the statement is always true. So if P then Q is true, then if not Q, then not P will always be true. This is not a if or maybe, guys. Again, if the conditional is true, I promise you that the contrapositive will be true. But that does not apply for the inverse or the converse. Does that make sense, my brothers? Okay, I see you guys writing, so I don't want to stress you out. I'll give you a few seconds. Okay, now, this one, take a deep breath for this one, okay? Chain of reasoning. Okay. Chains of reasoning are quite fun. Each proof that you complete involves a series of steps in a logical sequence. In many cases, my friends, the sequence will take the following form. If P then Q, and if Q then R, then if P then R. So basically, if P then Q, and then Q, then R, you can replace the Q with the P since the P is leading to the Q. Okay? This takes time to understand. This is called the chain rule. And a series of conditional statements so connected is known as the chain of reasoning. For example, if you study hard, then you will earn good grades. That's my if P then Q. And if you earn good grades, then your family will be happy. That's my if Q then R. My conclusion, we can conclude that if P then R. That is, if you study hard, then your family will be happy. That is a chain of reasoning. Okay? The good news, that's it for the lesson. I'm going to give you a couple sample problems now, but that's all you had to learn for this lesson. Yes, sir, my brother. Oh, is it kind of like the DirecTV commercials? Actually, yes, that's pretty good. Yeah, if you don't have cable, then you go to the forest. And if you go to the forest, you can't eat. And if you can't eat, you turn into a homeless person. Yeah. That's good thinking, my man. I'm very proud of you. All right. Now, shh, guys, come on. Now, sample problems. Let's check it out. I want you to write the converse, the inverse, and the contrapositive of the following true statements. Here's my conditional, guys. If two angles are right angles, then they are congruent. Who can tell me what the converse is? Yes, sir. Wow, that was perfection. If two angles are congruent, then they are right angles. Fantastic. Fantastic. You reversed the conditional. What is the inverse? Remember, the inverse negates the conditional. Yes, sir, my brother. If two angles are not right angles, then they are not congruent. Wow, you said it exactly the way I did. I'm very proud of you. Phenomenal, son. You negate the conditional for the inverse. And then who could give me the contrapositive which negates the converse? Come on, someone other than my boy here. Come on, guys. Try. Yes, sir. You forgot the if, though. If two angles are not congruent, then they are not right angles. And again, look at the conditional and look at the contrapositive. They're both true. If two angles are not congruent, they can't both be right angles. Because if they were both right angles, they'd be congruent. Does that make sense, guys? Yeah? Okay. Awesome. Now, let's do a little chain of reasoning problem here. I want you to draw a conclusion from the following statements. If gremlins grow grapes, then elves eat earthworms. If trolls don't tell tales, then wizards weave willows. If trolls tell tales, then elves don't eat earthworms. Okay. The chain of reasoning is formed by rearranging statements and using contrapositives as needed to match symbols as follows. I'm going to go ahead and guide you on this one, guys, because I don't think anyone's going to be able to get there. Okay, go ahead. You want to try? No. You're close. The first one would be, if gremlins grow grapes, then elves eat earthworms. Okay? Then from there, yes, sir, my brother. That's why I said you, sir. No. Close, though. Sir? No, but close. No, but close. No, but close. If elves eat earthworms, yeah, what's next? That's the chain of reasoning, my brother. If elves eat earthworms, then trolls don't tell tales. That's equivalent to number 3 above. Now, what happens if trolls don't tell tales? Sir? Very good. If trolls don't tell tales, then wizards weave willows. And then what can we prove from all of this goodness? Yes, sir. No, because we already have that. Sir? Sir? I'm so proud of you guys, but no, no. Sir? Oh my God, you almost had it. If gremlins grow grapes, then wizards weave willows. Well done, gentlemen. Look at how we did this, okay? Let's look at how we did this, guys. The statements were if gremlins grow grapes, then elves eat earthworms. If trolls don't tell tales, then wizards weave willows. If trolls tell tales, then elves don't eat earthworms. So we're going to use this information and rearrange it to get a conclusion. So we said we're going to start from the beginning. If gremlins grow grapes, then elves eat earthworms. But we know that if elves eat earthworms, then trolls don't tell tales. Okay? It's the negation, it's the contrapositive, basically, of number 3. And remember, if number 3 is a conditional, the contrapositive will be true. And then if trolls don't tell tales, then wizards weave willows. That's statement 2. So then, well, how do we put it all together? If gremlins grow grapes, then wizards weave willows. Yes, sir. You cannot skip straight to the answer, hence the chain. I'm not being sarcastic, but that's the whole point of the chain. Yes, sir. 3 did matter, because without 3, we couldn't have had statement 2. If elves eat earthworms, then trolls don't tell tales. We used the contrapositive, which negated the converse. Sir. Well, there could be a lot more than 3 statements, but in this case, there were only 3. Guys, perfect timing. That's the bell. You guys are awesome. Thank you. Follow the homework. We have a quiz on Wednesday, tomorrow. Good luck and thank you. I hope you learned a lot. Have a great day.